Hey, this is Joe, and today let's talk about the basics of the power rule for derivatives. And you use the power rule whenever you have functions or variables raised to power and you're trying to find the derivative of that function. So let's assume we have some function f of x equals x raised to the n power. And we're told to find the derivative of f of x. And you find the derivative by using the power rule. And that rule is you take the power, which is n here, and you bring it down to the front, so we multiply x by n. And then you subtract 1 from n, and you make that the new power. In other words, the derivative of f of x is going to be n times x to the n minus 1 power. So why don't we use an example? Let's say we're told we have to find the derivative of f of x equals x to the third power. Using the power rule, we bring the 3 out front, and we raise x to the 3 minus 1 power, which is 2. And so our derivative is f prime of x equals 3x squared. So let's move to another example. Say we want to find the derivative of f of x equals 5x to the 7th power. Using the power rule here, we bring the 7 out front, but when we bring it out front, we're going to multiply it by 5. We're going to multiply the two coefficients together, and then we're going to raise x to the 7 minus 1 power, which is going to be 6. And so our derivative ends up being 35x to the 6th power. And the 35 comes from multiplying the 7 with the 5. So let's work with a bigger problem. Say we want to find the derivative of f of x equals 2 times x to the 5th plus x to the 3rd plus x. Here we have 3 separate terms, and when we're finding the derivative, we're going to really just take the derivative of each term by itself and then add them all together. Now if we take the derivative of 2x to the 5th, we're going to get 5 times 2x to the 4th. And the derivative of x to the 3rd is going to be 3x to the 2nd. And the derivative of x, which is the same thing as x to the 1 power, is going to be 1 times x to the 0 power. And so, if we were to simplify everything, we're going to get 10x to the 4th plus 3x to the 2nd plus 1, where x times 0 is technically the same thing as 1, and so 1 times 1 is going to give me that constant at the end. And so now I just want to do a small conversation about detecting multiple derivative rules within problems. In other words, this power rule, whenever you're dealing with just a polynomial, is kind of easy to use. But say we have this function here, f of x equals x squared times sine of x. We would have to use the power rule and the product rule together to get the derivative. And then if we look at g of x, which is the quantity of x squared plus 4x all raised to the 4th power, this is going to use the power rule and the chain rule together. Looking at h of x, which is x squared plus x plus 1 all over x squared plus x, this is going to use the power rule and the quotient rule. And finally, if we look at j of x, which is equal to the quantity of 2x squared plus x to the 3rd power, all that times cosine of x, all of that divided by x plus 1, this is going to use all 4 of the rules. And so just knowing the power rule isn't enough to find the derivatives of all of these functions, although the power rule is used in them. And so it's really important that as you're learning how to find derivatives of functions, you learn how all these different rules work together so that you can find the derivative of any function. So hopefully you feel a little bit better with the power rule, and I'm Joe, and thanks for spending some time with me.